Hey everybody, today we are going to be going over lesson 2.6, applying proportional reasoning to solve problems. It's on page 21 through 23, and it's going to say I can determine whether a relationship is proportional and use representations to solve problems. So let's get going. So in example one, this is going to be a lot of word problems today. So example one says the ratio of collectible cards that Sean owns to the cards that Stephanie owns is 5 to 2. Now we can write 5 to 2 as 5 to 2 with a semicolon, or I mean with a colon, not semicolon. Or you can say 5 over 2 like we've been saying, or you can say 5 to 2. Either way, all of it means the same thing, that they are in a proportional relationship. For every 5 cards that Deshawn has, Stephanie has 2 cards. So Stephanie has 36 cards. How will the ratio of cards to Deshawn's cards to Stephanie's cards change if they both sell half of their cards? Well, first we need to figure out Stephanie has 36 cards. How much does Deshawn have? They didn't tell us that, so we need to figure it out. So normally we make a table, but I wanted to show you guys another method that we can use. It's called a tape diagram. And in a tape diagram, what you're going to do is you're going to write out what Stephanie has. She has 36, and we're trying to figure out what Deshawn has, and we'll put him as X because we don't know how much he has. Now, we know that the ratio is 5 to 2, so I know 2 boxes for my tape diagram are going to make up Stephanie's, and my boxes are kind of messy, but here you go. And so in each of those boxes is going to make enough to make 36. Well, that would be 18 and 18. 18 times 18 gives you 18 plus 18 gives you 36. Well, I know comparatively Deshawn is going to have 5 boxes. So 2, 3, 4, 5. I'm a little short, but close enough. Made my first one too small. And these boxes are still going to be worth 18 because it's a proportional relationship, so each box is worth the same amount. So if I have 18 5 times, then that means 18 plus 18 plus 18 plus 18, or 18 times 5 means that our X equals 90. So when she has 36 cards, he has 90 cards. Now, this might have been a little confusing for you, but if we just did our proportional relations like we were doing before, it would look like this. I'm going to put my or, and I'm going to say 5 over 2, and that should equal the same as whatever over 36. Well, how do we get from 2 to 36? We multiply by 18. And we're going to do the same up here. And this is literally what we just did in the tape diagram, just in a different form. 5 times 18 gives you 90. So we know Deshawn has 90 cards if she has 36. So let's go make our table and say these are Deshawn's cards. These are Stephanie's cards. And we'll say, well, the original ratio was 5 to 2. The cards they have right now is 90 to 36. And we want to know what half of that is. So I'm going to multiply by 1/2 or divide by 2. Multiplying by 1/2 is the same thing as dividing by 2. Well, if you multiply by 1/2, that's going to give you 18 for Stephanie, and 90 divided by 2 or multiplied by 1/2 is 45. So our new ratio, and the answer is Deshawn will have 45 cards, and Stephanie will have 18 cards. And that's your answer. We used our ratios and different methods to find out what their new cards would be. Now we're going to go ahead and move on to example 2. Martin is 6 years old when his sister Cassandra is 3 years old. How old will Martin be when Cassandra is 6 years old? Now, we've been using proportional relationships to find all of our stuff, but right now we haven't been told this is a proportional relationship. So first thing we need to do is this a proportional relationship? So let's make a table and find out. I'm going to put Martin over here, Cassandra over here, and we know how age works. So she's 3 and he's 6. Well, we don't actually multiply to get to another age. We could if we want to say, well, when she's 6, how old is he going to be? Well, I'm not going to multiply, though, because I know how age works. You add one every year. So I know if, as she's 3, then she'll be 4, then she'll be 5, and then she'll be 6. And you just add one, right? Plus 1, plus 1, plus 1. Well, if I'm going his ages now, when she's 4, he'll be 7. When she's 5, he'll be 8. And when she's 6, he'll be 9. And again, that's just our plus 1. I'll move this a little bit. So now we have our ratios, and we got to see if they're equivalent. So we need to say 3 over 6, which is equal to 1/2. We have 4 over 7, which cannot be simplified. We have 5 over 8, and we have 6 over 9, which is equal to 2 over 3. So now I'm just going to bring these down so I can compare them. And we see that this does not equal this does not equal this, and this does not equal this. So therefore, they are not proportional. Our ratios have to be equivalent for them to be proportional. But the question wasn't, was it proportional or not? Our question was, how old will Martin be? Well, when she is 6, Martin will be 9. When she is 6, Martin, I should probably capitalize his name, Martin will be 9. And yeah, age isn't something that's proportional because we don't go up we go up the same age every year, but it doesn't go up at a proportional rate. So that's it. Tomorrow, when you guys come into class, we'll go over example 3 and do the try it, and then you guys will have these. You're actually not going to do these practice problems. You can cross them out. I thought I liked them. I didn't. You'll have your Math Excel after the example, and then you're actually going to do a quizzes. So if you have any questions, let me know, and I will see you guys soon.